Hi folks, we're going to take a look at question 8 on page 103. So what they're asking us to find here is the symmetric equation of the line through the origin, and that's parallel to the line passing through these 2 points. Okay, so when we're trying to find the parametric vector or symmetric equation of a line, what we need is a point. Okay, we need our R0 on the line, and we need our direction vector M, which is parallel to the line. So, and in this case here, be aware that they're asking us for the symmetric equation. So even if you find it in another form, make sure your final answer is in the form requested. So first thing I notice here is that it tells me that the equation, that the line passes through the origin. That tells me right off the bat that a point on the line is 0, 0, 0. Okay, so there's my R0. Now, it tells me that this line is parallel to the line passing through these 2 points. Now, if 2 lines are parallel, it means they can be described using the same direction vector. So if I find the direction vector for that second line, I'll have the same vector that I can use for the first line. And since I'm given 2 points on that other line, I know that I can create a direction vector just by subtracting those 2 points to get the vector that joins them. Okay, so in order to find my direction vector, I'll just take this here, and I can go -2 minus 4 is -6, and then -4 minus 3 is -7, and then here I've got 3 minus 1 is equal to 2. Okay, so here's my direction vector. Now, since I can use any direction vector I like, you know what? I'd rather use the one that's got fewer negatives in it. So as an alternative, I can use as my direction vector 6, 7, -2. Okay? But now that I have a point and the direction vector, it's just a matter of writing out the equation. Okay? Now, since they're asking for symmetric, but we might as well write all 3 out. So if they were asking for the vector equation, well, it would just be my point 0, 0, 0, okay, plus my parameter t times my direction vector. So in this case here, I'll take 6, 7, -2. If they were asking for the parametric equations, it would just be the same thing, just with the individual components written out separately. So here x would be equal to, well, 0 plus 6t, so just 6t. Y would be 0 plus 7t, so just 7t, and then z would be 0 plus -2t, so -2t. Okay, and if I want to write it in symmetric form, well, it's x minus the x component of my known point, but in this case here that's just 0, so don't really have to write anything, over the x component of my direction vector, so 6. And then here it'll be y minus the y component of my known point, which again is 0, so I don't have to write anything there, over the y component of my direction vector, so 7, and then here it would just be z minus, again 0, so nothing to write, over the z component of the direction vector. Okay, and this would actually be the answer I was looking for in this question. Okay, that's it.